All right, why don't we get started? So thanks everybody for joining this week's seminar. We are very excited to have Dr. Jie Zhang to join us today. Professor Zhang is a tenure track research faculty at Atmospheric Science Research Center at the University of Albany, where he also did his PhD and was a research scientist before he joined as a tenure track faculty member there. He also did his postdoc at Colorado State before returning to Albany. Professor Zhang is an expert in air quality. He has a well-functioned mobile lab, which I'm sure he will tell us more about. He's also actively participated in multiple field campaigns related to air quality in the New York overall area. And just by reading his paper and chatting yesterday, he is an expert on Long Island air quality. I don't know if he'll tell us this, but for instance, he told me that South Bay or South Beach has a extremely bad ozone problem, which a lot of people don't really know about. So instead of giving his talk, I'll let Dr. Zhang to take away.
Okay, yeah, thanks, Minhao, invitation and introductions. So yeah, I just kidding with Minhao yesterday when driving back to here. It looks like I'm back to the home now because I took almost 4 summer in the past several years stay at Long Island. So from the 2018, 2019, 2022, and 2023, my mobile lab is 3 years, the whole summer parking at the Flex Pond Marine Lab, and 1 year's parking just beside these buildings. So yeah, so I just kidding. Should I just at that time I should transfer my PhD from the Albany to Stony Brook to finish a PhD here. So this talk is almost the result for the past several years using the mobile lab to focus on the Long Island's high ozone events. This time I'm more focusing on the south shore of Long Island. This integrating my mobile lab measurements, especially also with the new type of measurements to show how it looks like the high ozone events over the south shore. So Minhao quickly introduced me. Yeah, so I graduated from the University at Albany. Then I go to the CSU. After that, my supervisor Jim called me. Yeah, I need to come here, continue driving the mobile lab. Then I come back to the Albany and then take over his position after his retirement. So background, this is the first introduced our mobile lab. This is a very old versions because this mobile lab is back to almost over 10 years ago. They first designed this mobile lab to focus on still go to the New York City. But then after that, they never use it until recently. We started put the instrument on it and go to different field campaigns. The first figures we show, this is the last 2023 and 2022, we're talking at the Flex Pond to cooperate with some of the NASA ozone radar team and to cooperate with the Aloma research scientists. So this is from the 2007 Dodge Sprint 1. It held the battery. At that year is around 13 kilowatt hours. Right now, I put more batteries. Totally, the whole will be over 20. So that will support my instrument for over 10 hours. I can no stopping, keep driving for the whole days. So I have 2 inlet, is one for gas and one for aerosols. The mobile lab is big enough. It's a big enough so that I can put more instrument to put the mobile lab so that I can get more species from the aerosol to gas. Normally for the in the past field campaigns, normally this is normally instrument is used for the gas, trace gas, the ozone, NO2, CO2, and formaldehyde. For aerosols, we're using the very old versions of the AMS for aerosol chemical compositions because we want to know organic, sulfate, ammonia, and other species. Especially want to tracking how the aerosol chemical compositions variation following the emission variation, something like this. So there is aerosol total mass. I was using the 2 PDR. This is optical instrument. I using the optical instrument want to focus on the aerosol liquid water. This is recently we find this optical instrument can have a theory, can capture information about aerosol liquid water. Then we can know the ability to absorb the aerosol ability to absorb the water. So for also there has an aerosol number concentration. At that time, we don't have the VOC. So we just simply to stop there, open the canister, collection the canister, send it back to DC, help us to analyze it. Also in the 2018, we also, when we're parking at the flux bond, we're using some of the VOC data from the Zhang's group, from Zhang's PTRMS. So this is how it looks like. Also, you can find there's the tube. This is the cold air from the AC to cool down the mass spectra, because the mass spectra is really temperature sensitivity. So this is normally how while driving, there's different smaller monitor to monitor the performance of different instruments. Okay, started the story is back to 2018. Let's do the study. This study is organizing, want to focus on how the New York City urban plumes transport over Long Island, especially focus on Long Island Sound. At that time, my mobile lab is first to come here to driving around the Long Island Sound to focus on the high ozone events. So this is yeah, we got it. On the July 1st, on through my mobile lab measurements, we captured what they described in the white papers of the Long Island, the list of studies, high ozone in the North Shore of Long Island. But there is special case because special case I'm thinking, how about the South Shore? Because even the listos is not mentioned. I'm thinking I should go to the South Shore, have a look. So when I'm driving there, I really found a very interesting phenomenon is happened near the Faird Island. The ozone concentration is quickly from the 60 ppb to over 100 ppb. Looks like a wall there. The spatial gradient you can find is almost 20 ppb per kilometers on the South Shore. Then we look at the air quality forecast by CMAC at that time. You can find there's nothing at the South Shore of Long Island. This is the attract our attention to find out what's the problem, what's the mechanism, what's the factors will cause the high ozone over South Shore of Long Island. At that time, we don't have very clear idea. We found a series is most likely we thinking is related to the sea breeze circulation. At that time, the theory is I think is not totally correct, because we found the sea breeze circulations. We made is also if you look at the back trajectory, also you can find the back trajectory first move to the ocean, then transport back. At that papers, we simply to summarize is caused by the sea breeze circulation. Then in the next you will find the series more and more detailed about this. At the same time, we also found this is with high ozone period. You can find that there is also with the high ozone events, the aerosol number concentration, aerosol mass concentration is also increased. Also the sea salt aerosols. Definitely, this is in the maroon conditions. So after that, we have a question. What's the frequency of the high ozone events around the South Shore or compared with the North Shore? And what's the prediction mechanism driving this observed difference? Because these papers just a special case, we cannot answer these questions. Then after that, my supervisor Jim Schwab get a special funding from the NSODA to ask us to set up a special measurement site in the South Shore of Long Island to try to answer these two questions. So we set up from the 2021 to 23. So this is the normally location of about Hector State Park. This is we borrow this shelter from the DC. We put just put the ozone, NO2, and the chemical collection in this shelter. This is also I just take a picture on the roof about this special site. So we set up to better understand the ozone difference between the North Shore and the South Shore. So how it looks like. So here just to show the 2021, the first year the data. Over the first year, we found 15 days have the ozone difference. Among them, have 10 days have high ozone in the North Shore and 5 days high ozone in the South Shore. This is why the list of the focusing definitely at that year, North Shore have more high ozone days than South Shore.
Could you just remind us what's the EPA standard for ozone?
8 hours and 72 ppb.
72?
Yeah. But here just the hourly is just a short time. Yeah, short time. So based on this 2021 data set, we just simply to try to explain what's the mechanism for the North Shore high ozone events and the South Shore high ozone events. For the North Shore high ozone events, this is normally as expected by the list of studies. So this is our ozone valuation. You can find at this, you can easily to find the ozone difference between the Hampshire State Park and other DEC site. All the DEC site is normally in the middle of Long Island. Also, there's one site at the Flex Pond. So at that time, we don't have the model simulation. I simply use the HRR to explain why it's caused it. So while you look at the HRR, it's normally in the morning time, there is calm conditions for the New York City and the west of the Long Island. You can assume the morning emissions were trapped at there. From the moon, there is a sea breeze formed. The sea breeze will strong enough to from the moving from the south to north. And almost at the 2 p.m., they will almost near to the South Shore. They will push you can assume the pushing the urban plumes go to the Long Island Sound. And at the 4 p.m., after 4 p.m., this sea breeze will stay just at the North Shore of Long Island. The Long Island Sound will trap all the plumes so that you can assume there's high ozone formed around the Long Island Sound from the north of Long Island to the South Shore of the city-state. But for the South Shore, the story is some different. For all the 5 days of about how the high ozone in the South Shore, we normally find there's how the high peaks ozone around at the late afternoons. We're thinking the mechanism maybe have similar mechanism, but we will look at the different of the spatial distribution of ozones with the mobile lab measurements and the DEC set, we still find some different. For July 15 and July 27, the high ozone just at the Hampshire State Park is very, very, very south. In the June 9 and August 27, these high ozones will extend to the middle of Long Island. And also June 26, you can find that there is very flat high ozone. For high ozones is almost for 5 hours. So still there are some different factors causing related to different phenomena. So we separate to 3 different factors. The 3 factors, the first one is the low-level jet. So why we look at because when I look at the high HRR model simulation, at that high ozone times, the sea breeze almost near the North Shore of Long Island. This is not related to the sea breeze at this moment, we're thinking, because the sea breeze front almost passing by. So why still have the high ozone happened? So this is when then I look at the wind speed, definitely found there is increased the wind speed over the South Shore of Long Island. But I'm not special to folks. We assume this is low-level jet happened at that time. If the low-level jet happened, So you can assume the urban plume at the previous the morning time, the land breeze will carry the land wind will carry the plume go to the ocean. When the late afternoon, when the ocean flow carrying the plume back, when they meet the low level jet, will stop there. So this is caused, we think, caused the high ozone, and just at the south shore of Long Island. There is another case. Recently, we're thinking more and more focus on this case, is the returned urban plume will blocked by the weak sea breeze front. Because when you look at this one, the sea breeze front is very strong. It's almost quickly to moving from the south to north. But for the weak sea breeze front, when you look at the HR model simulations, it's almost it's a long time. It's almost from the 12 to the late afternoon. All these sea breeze front will stop at these locations. In this case, if the urban plume will transport back, it always will stop in the north side of the sea breeze front. It cannot move forward to north. You can assume the maroon boundary layer is very low. All this plume will trapped in this narrow maroon boundary layer level. It definitely will cause concentrations very high. So this at that years we only captured 2 cases for this phenomenon. Also, this is 2021. Also remember, it's arrived in the middle of Long Island. Also, we compared with the Queens College and Hector how the ozone variations respond to the NO2 reductions. We easily to find at Hector State Park the variation, the ozone protection rate prepared the NO2 is much higher than Queens College. This identified this is the NO2 limited conditions compared to Queens College, but we still cannot verify it. This is why I will show using the typo to verify this. There's another very special case. There is the third factors. This is the maroon, the return flow urban plumes blocked by a synoptic flows. You can find that the regional synoptic stationary front stop here for several hours. They also will block the urban plume transport back. So I just show the figures. So the HRR performance good because this is the location for the cloud formation. This is from the satellite. It's really matching each other. So want to show the HRR is it's okay to have Earth to explain why is the high ozone formed in the south shore of Long Island. So normally, to sum of the mechanism about this kind of high ozone and the south shore included, the transporting urban plumes over Long Island, to the Long Island South Oceans, then have chemical reaction to form the high ozone. Then this late afternoon maroon flows carrying this high ozone plume will back to Long Island, but it's blocked by other conditions. There are low level jet, weak sea breeze front, and the synoptic stationary front. But the question is, at that time, we only using the Hector State Park data. We don't know how is the spatial distribution of the high ozone regions. It's just the Hector State Park, or is along the south shore of Long Island. We don't know. We don't have data to answer these questions. And how with the time going, will the high ozone events over the south shore become more frequency or no? Also, what's the primary factors with the time going will control the high ozone events over the south shore of Long Island? To answer these 3 questions, we got the findings from the NYSODA to using the mobile lab to scanning Long Island to focus on scanning the south shore of Long Island to answer these questions. The total period from the June 21 to September 7th in 2023. Totally, I have 26 unload amendments, and for the remaining days, I just parking at the flex pond to let them to the continually amendments. So this is 2 pictures. Also, sometimes one day I driving the mobile lab to the ferry to help me to crossing the Long Island Sound to look at
Did you get special permission to park right at the front?
I just talk with the persons. I wanted to go to the front. They said, yeah, go. Yeah, you must arrive 1 hour ahead. You must be the first one arrive there. To talking with them. But I found the problem is when I go to the ferries, all the cars leaving their engine on. This is always I can find I get the signal from their truck engines. So this is the quickly introduction by my 2023 field campaigns. So I based on the aroma ozone forecast, especially I based on the HRR simulations for the sea breeze to determine which locations should I drive in. This is normally the driving map for me. In the early morning, I start from Flax Pond. I first driving the set points. Then I go to the south to Long Beach so that I can scan in the Long Island for 8 or 9 hours. So this is summary all the 26 measurements for this period of the aroma focusing. But aroma is focusing on Long Island Sound. But for the 2023 is Long Island Sound don't have special high ozone events because the high ozone events mainly happened in the south shore of Long Island. This is you can find this is all the red cases is the red high ozone over the south shore of Long Island. My mobile lab continue to scan in the south shore of Long Island. This is the special case for the south shore of Long Island with the concentration near 100 ppb. The highest concentration near 100 ppb. You can easily to find all these high ozone concentrations really over the south shore of Long Island, especially under the marine boundary levels. So for all the south because my mobile lab is always first we're driving from the Robert Morse State Park to Hampshire State Park. Then the Smith Point Beach and Quonset Beach, this is almost 70 kilometers. All have ozones, high ozone concentrations, or near 100 ppb. There's also the September 6th is the strongest ones. You can find that at that days, the sea breeze front is a little far away, go to Long Island Sound, but you can also count the ozone concentration is super high at that days, almost near 110. So this is because we're thinking all these 3 cases are influenced by steignic sea breeze front. This is the picture that show the sea breeze front is very weak. It's always stop at the south shore of Long Island from the moon to the late afternoon, almost 7 p.m. or 8 p.m. In this case, when the high ozone formed in the shallow marine boundary layers, the concentrations were definitely easy to over 100 ppb for that whole 7 or 8 hours. Also, why we cost very important for this because at that days is also sunshine days. When driving there, all the people enjoy the quality the sunshine. Or when driving the beach, is all clouded people. This is really harmful there for the cases. Based on the HRR simulations, we're thinking if you look at the HRR simulations, you can find the marine boundary layers almost near start from the Jones Beach Island. We're thinking this almost the whole areas will be 80 to 90 kilometers, but just from the HRR simulations. How to verify that? So at the same time, not only for ozone, we also want to focus on the aerosols. If you look at the time series, this is 1, 2, 3, 4. This is of the different locations from the Robert Morse State Park, Hampshire State Park. This is the Smith Point Beach, and this is the East Nut Beach. You can find with the high ozone, the aerosol concentration also increased. That is expected because the marine boundary is narrow. This is the concentration will be increasing. But more significance is the particle nitrate. You can find the particle nitrate increasing much significance than other organic aerosols. This is definitely because its RH is high. this is easily to form the ammonia particles. At the same time, we also kind of some of the IDM signals. This is really this we thinking the future because when the people want to focus on IDM related new particle formation, and the second organic aerosol from marines. This is south shore of Long Island will really good location to do such kind of study in the future. So right now we answer the first questions. What are potential high ozone regions? This is west from the Jones Beach, extending to very east. But for the left two questions, what's the yearly variation of the frequency of the high ozone events over south shore compared with the north shore? And what's the dominant factors of the high ozone over south shores? Our mobile lab cannot answer it. Then we analyze in the 3 years Hampshire State Park, try to answer these questions. The most significant ones we found in the 2023. At that days, there definitely have almost 10 days have a high ozone over the south shore compared with the north shore. South shore become more important things. Then I look at the factors, what to look at if in the 10 days, how many days have the weak sea breeze front? It's almost, you can find it's almost of these days how the weak sea breeze front at their days is caused by this. So the potential for caused that maybe the sea breeze, maybe the marine temperature is increasing, cause the temperature difference between marine and land decreasing, cause the sea breeze is weak. So that with the sea breeze weak, it cannot moving totally to the north of the Long Island. It always will cause the more ozone over the south shore of Long Island. This is definitely in the future. We set up the special set on over the south shore to focus on these phenomena. So we almost talking about these questions, but the major we rely on the HRR model simulations. So we need a directly special observation to identify the source and the chemical evolutions about ozone events. Directly, we want to show from the New York City. How to do that? Because the new table, we can look at that. This is the picture, our pictures I just downloaded from the new table. So it looks like from the 9:30 to the afternoons. You can from the morning time following the west wind, there is the plumes will moving from the New York City to over the south shore of Long Island. And with the time going, this plume have a chemical reaction there. Then with the marine, it's narrow and narrow, this ozone concentrations definitely will increase. So back to my formal questions. Is look because the formal question based on these figures, we're thinking the south shore is more NO2 limited because we so looks like each reduce the NO2, you have more ozone formed. This is also if you look at the tempo using the formaldehyde to NO2 ratios, you can easily to find with the time going at the south shore of Long Island. This is the ratio is increasing. If this ratio is increasing, it means the ozone formation regions more low related to the NO2 limited regions. At that time, its ozone is more sensitivity. So this is the final perspective. So because with the time going, if in the future the aircraft flying to our New York and downwind regions, we definitely need to more focus on the south shore of Long Island, especially with the heat wave and other phenomena. The heat wave it become more and more frequency. This is the south shore high ozone and the events will become more and more significant. Especially these locations, we are really easily to tracking how this with the New York City emission controls, how this is the will modify the air pollution events over the south shore of Long Island. Also, there's a good location to focus on marine atmospheric chemistries. But at this moment, when we talk with the DC, this whole area, there's no DC site or EPA site. They only have the meteorological or the mesonet data, but it's from the Wanta, it's still 20 kilometers from the south shore of Long Island. That's all empty for this whole regions. We wish to set up more site to focus on this area. Oh, my logo is disappeared. Yeah. This is logo, my mobile lab. Yeah, thank you, especially thank you for NYSODA. Thank you, the Stony Brook University for supporting the field campaigns, or especially thanking Flex Pond. We really take care of the mobile lab. Yeah, thank you all.
All right, thanks, Jie, for a wonderful talk. We have a lot of time for questions and discussions, and I know this is relevant to a lot of our research here. So yeah, Paul, let me go ahead.
So really interesting. Early in your talk, you showed data from the drive from looked like Flax Pond down to Great South Bay. And it looked like very high ozone. Yeah, so the bottom figure there. High ozone localized over Great South Bay. So that looks to me like local production. The reason I say that is, it's pretty hard to get local high ozone through transport.
Yeah.
You got to be making some. So I'm just curious if you have any measurements of VOCs and NOx when you're on that bridge over Great South Bay. I'm just curious about, there's a lot of marine emissions. Mixing is poor. Marine engine emissions is what I mean, that have no emission controls. It would be interesting to just see what VOCs and NOx looks like along that.
Yeah. So should I repeat the question from the online person or doesn't matter? Yeah. So for VOC at that time, we don't have VOC instrument. Even at that time, we even not realize there's high ozone events. We even not carry the canisters, which for me it's just for fun, such that they is driving to there. But for the NO2 concentration is still very low. It's almost 2 ppb or 4 ppb. This is why we're thinking it's not directly at that time. That point is not to form from the NO2 transporter ozones. Maybe they transport from other locations. Yeah, but for VOC we don't have the data.
To have higher concentrations over Great South Bay, it's hard to get that just from transport. You think you see it all over the south side of Long Island.
Yeah, we're thinking this is almost transport always, as I mentioned, the local emissions, they just trapped there, as cooking there to form that.
What day of the week was it?
What's the day?
Day of the week.
Oh, days the week. So I forgot it. Should I quickly check it? So
There's a lot of recreational boating
yeah,
on the weekends.
but we quickly at it.
Yeah, mixing is poor and no emission controls. Just
Saturday.
curious.
Saturday.
There you go.
Yeah. Yeah, also this is why we thinking this is focus on this at this location we want to then extend the long distance.
And just take the opportunity to remind everyone that we have the Great Lab on Shinnecock Bay, which is to the east of Great South Bay, but it's got a roof, and that roof seems to be sitting there year round.
Yeah.
That would be a great location for some of us to make measurements in the summertime and see if it's a general phenomenon along the south coast.
Yeah.
Very interesting.
It's very last for the future, many years measurements we can see. So if the sea breeze is always with the time is weaker and weaker, or just the 2023 is the year special years. Yeah.
Yeah, what you're describing is actually very similar to what we saw during Listos along South Shore of Connecticut.
Yeah.
With that jet.
Yeah.
So we saw the low lying jet with maximum ozone concentration is like 300 to 500 feet off the deck. Coming from the west.
Yeah.
So if your sea breeze is holed up, you know, on the South Shore, which is kind of odd at 4 o'clock, but maybe that jet, instead of having propagated across Long Island, just parked itself
Yeah,
off the South Shore.
Yeah, well, that one,
We've seen that
that
jet.
one case you show with the northerly background flow will keep that sea breeze on the South Shore, guaranteed. It's a large scale flow,
Right.
it's gonna fight it, so
Yeah.
that's one way to keep the sea breeze. On the
Right.
South Shore, is having just weak northerly winds on the background, and you showed that one case with trajectories that was like that.
Yeah.
Not sure about some of the others, but,
I think,
Cause I'm guessing your high ozone on the South Shore, if you were up 300 to 500 feet, that's where your max would be, because that's where what we've seen along the South Shore of Connecticut in years prior.
yeah, the low level, yeah, the low level, yeah.
And our max ozone was like 400, 500 feet off the deck.
What was the value?
It was high. 180, I think it was maximum. That was in 20, I can't remember. That was years before this. But yeah, with that northerly flow, maybe that location, the propagation of the northward movement of that sea breeze in the afternoon.
that's why you would see a difference between North and South Shore. I guess I mean. For the South Shore, there's sources upstream, New York City is giving the source, is the source for the North Shore on New York City, but for the South Shore, is there a Philadelphia component?
Yes, some cases Philadelphia, yeah,
Yeah, so it's coming across
coming across
that way,
the ocean,
and
yeah,
then the question is, it's in the boundary layer and then may not be able to make it up.
Yeah.
Sea breeze constraint. So I guess the question is, what is the source on the South Shore? It could be local, a little bit, but there's clearly probably some upstream sources and may not be even New York City. Right?
Yeah. So because for the 2023, there's special high ozone case, only this case have the ozone plume transport. For others, these two case, for September 2 case, if you look at the tempo pictures, there is the New York City urban plume is not transport to these locations. This is normally maybe from the other previous New York City emission or from the Philadelphia, Washington, DC, they go to the ocean. Then finally, all the ocean plumes will go to the Long Island regions, trapped there.
Do all the back trajectories look like the air mass had moved from a source region from either all of that dirty northeast corridor or New York City? Like in all the cases where you have high ozone on the South Shore, the back trajectories.
From the New York City, but others, I remember, I forgot which one is one special case I can find that the room is from Washington DC, Baltimore regions transport there.
Yeah, the other thing I was gonna, obviously getting more measurements, the marine boundaries there is
Yeah.
important, but there is a mesonet site at Wantock, right? That
Yeah,
has a
so-
radiometer and a profiler and it should give some.
So
estimate.
the question is, one part is just the out range of all the sea breeze front for all the 3 cases. Yeah. So we try to measure the few move a little south. This is the only location that we can find. We're thinking maybe future can set up a special measurement study there to just to focus on this phenomenon long time in the future. Yeah, that's
How much does Long Island itself, like through commuter travel and residential housing, contribute to the overall ozone concentration? So I can see that under northerly background flow, that you could almost see that morning time pollutants would somehow get focused on the South Shore, and then the sea breeze kind of combine those into a strong layer.
the answer is not very clear because at this current based on the measurements, but just describe the problem. Then in the future with the model simulation, they can separate the different source. Which mentioned at the branch which I mentioned that some source maybe from the local, some source is from the New York City, some source maybe from the Philadelphia, Baltimore, Washington DC regions. In different case to different case. Yeah. At that time, just based on the measurements, it's not very clear to separate different factors. We just mentioned it's possible that plume is there was the factors maybe cause this phenomenon to identify the problem and maybe cause the future attention something.
I have a question. So obviously, like the tempo data only started 2023-ish. Like if you go back time, like looking at data from troposphere or OMI, like I guess the question is first, like is like by looking at those data, can you get any information on this South Shore ozone problem, or is just the temporal resolution doesn't really give what you want there?
Triple
Troposphere, okay.
Yeah, this is the triple omi. You can still find from the triple omi, you can find the plume from the New York is, for this special case, the plume is there. From the New York, they covering the South Shore of Long Island.
I guess then the question is, if you go back time, like, I don't know, starting from 2017, where you have troposphere data,
Yeah.
like analyzing data from 2017 to 2023, like, do you expect to see more this kind of events?
Yeah. So for the 2018, the paper, they also have the triple omi data. It's also have some plume related to New York City.
So like, this is definitely not just a 2023 problem.
Yeah. But the one analyzing, I find more and more complicated. Yeah.
Speak about it, right? So you're presenting a lot of questions, right? If you assume, right, the line is interesting of the topic, right, some way put money there. Right? What is the best way to design the future? Just drivers away, working surface is not enough.
Yeah, so because for example, almost the sources in Minnesota, they want to focus on how the air pollution will, how the effective the emission controls. So if we design definitely for the Long Island Sound, I think set up a special site there. So maybe a core site with more instruments with the ground measurements, or the vertical profiles. So at the same time, we can also combine with a central site, also combine with some of the low cost sensor just for the ozone or something along the line. So using less money along the South Shore of Long Island, maybe from the New York City, then go to the government island, go to the Long Island beach, go to the John's Beach, go to Robert Mossberg, following the lines beside the central measurement site. Also can combine with some special days, combine some mobile and aircraft measurements. But with the site there, maybe for the next 5 years continuing measurements, we can definitely show what the variations following the emission controls, also the phenomenon, the sea breeze phenomenon become what's the variations with years, something like this.
Did you see strong gradient across the Great South Bay?
Strong
Gradient
gradient,
across the Great South Bay.
yeah. So, but the Great South Bay across the bridge, normally we see the gradients there. But when you're driving the Barrett Island, is all uniform.
Sort of south north gradient across the bay.
Yeah. So when driving the brightness is very high. Normally it looks like a wall, quickly increasing. Yeah. So it's not looks like other phenomena is slowly increasing, slowly down. It looks like you just go to a different world. It's suddenly it's increasing, then keep it uniform.
I mean, the Great South Bay is effectively behaving like the ocean.
Yeah.
Fire Island isn't changing anything right there, so it's just the marine layer. You can basically connect the dots so many days, and then, yeah, sometime when you go over the bridge to Robert Moson's,
It's totally
it's like a wall, like you said, but that's the marine influence. And so whatever's going in Great South, that's the issue, how much is local, but there's also the fact that it could just be an extension of what's going on at the coast. Or over the ocean part of the Boundary area, and then makes it to Great South Bay and then stops.
Is it a front or is it local production? That's, I think.
Yeah, well, the source is a really question. So if you're designing experimental things, I mean, that what worries me is if you have one site, you can understand that site, but you still have the question about the source areas and what's going on just off the coast, right?
Yeah.
So ideally, it seems like you would want some measurements
Yeah,
just south of Long Island
Yeah, no,
to,
Winfield is off.
yeah, you need to kind of know that
It's
gradient.
most likely transport, so you wanna know the wind field, I think, out the South Shore. So you need a boat with a drone, or you need a plane or something, you need that 3D,
3D vertical information.
Yeah.
Something.
I'd say.
Yeah, so.
I say the meteorology is even more important than chemical measurements, because I think if you could map the wind field. I'm pretty sure there's a jet on the South Shore on that day. Which is analogous to what we've seen on the South Shore of Connecticut. I'm pretty sure you have a jet, a westerly, low line, narrow jet. Which is indicative of the position of the front of your sea breeze location, right? In the afternoon.
Yeah, so that is definitely for vertical information, when also the ozones maybe, if designed, maybe.
And it'll be higher, and then you just got this jet coming from the west, and it's
Yeah.
gonna be off the South Shore, right? So what you're picking up, I'm guessing, is just kind of the residual being dragged along by that jet. Yikes. I'm guessing your ozone will probably be even higher off the dam.
The higher levels maybe.
Yeah,
higher.
not much higher, 300, 500 feet. That's what we saw off this coast of Connecticut.
Yeah,
So
so,
if you could do that, then you could say, I mean, transport is so important for this stuff, right?
yeah. So we still need to, ozone layer and the wind layer also.
Right.
Kind of data
Right.
To put.
Which you wouldn't need much more, I don't think, right? Ozone, maybe NOx, and what, but wind, you gotta have your wind,
Yeah,
temperature.
so normally for the ground side, normally, as you mentioned, this is even using the low cost ozone, something like this should be fine, but the more important for the vertical informations, 3-dimensional informations, we need that.
Yeah.
Or maybe put a Picaro or Pandora there to also can help to validate the tempo measurements, special for these three regions. Yeah.
Yeah, Pandora. we could use it.
Any other questions for speaker? If not, please just join me to thank the speaker again and thank everybody. And please join us for lunch. Okay, sorry, let me see if actually any question on. Have you tried to evaluate?
Yes, yeah.
Minhua, are you still there?
Yeah. So I have a question typed in the chat box.
Yeah, so meanwhile, yeah, so normally the boundary layer height is the dominant factor for the high ozone. Because the marine boundary layer just based on the HR model simulation is just 40 or 50 meters is normally the dominant factor for ozone, the ozone mixing ratios. Even because even the absolute amount is low, but the marine boundary layer is too narrow. This is the mixing ratio is super high. Yeah.
Okay, thank you.
Transport.
Yeah, thank you.
Right, thank you. Thanks everybody on Zoom.
Chat.